Uh-oh, uh-oh. All right, watch this. Last Friday we went outside, for those of you who are here, and some of you were making fun of me because you didn't understand how what I was teaching you on my little easel board relates to smartphone technology. See, Rodriguez is already laughing at me. I'm not. So when we're outside, if you remember, actually, you know what? This thing's a little bit off. Stay with me. So it's the second to last lesson. Focus, focus. Shoot. So when we're outside, recall I made a small right triangle and then we made it bigger, bigger. But this angle stayed a certain amount of degrees. You guys remember what degrees it was? 84. It was 40. The ratio became 84. So watch, this was 40 degrees. That's an acute angle. Now if you remember, we started off with this is 5, this was 5, and this is some other value. This was 7, this is some other value. Right, okay. So and it every time the ratio of this side to this side was always 0.84. Always. Okay, so now, that's where we left off. And some of you are like, man, what does that have to do with smartphone technology? What does that have to do with ICBM nuclear missiles, intercontinental ballistic missiles that we can fire from here to North Korea? All that would be impossible without trigonometry that I'm about to show you. It also makes possible the fact that the United States is a superpower. We can do calculus, we can do advanced mathematics. That's what separates first world countries from third world countries. Not only the peace that their governments provide for the people, but for advanced mathematics that make possible the weapon systems that we produce. So then I asked you, what if I was standing here? Here's Mugia. Yeah, there's Mugia. I'm going to put a little Dodger hat. Here's my Dodger hat. And I said, look, if this is still 40 degrees here, then the ratio of Mungia, this side, to this side is still going to be 0.84. And then I said, let's take it a step further. What if we have a tree here? Let's put the tree in green. After all, leaves are green, right? So here's a tree. If this is still 40 degrees and we still have a right triangle, look at that. Look at the 90 degrees never changed. That means the ratio of the tree to this side now is still going to be 0.84. And then last but not least, what if we make the triangle so big that we get the moon here? Here's the moon. That means the height of the moon to this, the ratio of the height of the moon to this side is still going to be 0.84. The ratio is this side to this side in a fraction form. So let's just say this is, well, let's say 6 feet. So my ratio, that's 6 feet over however amount of distance this is, let's say it is 12. That would be 0.5. Let's say 8. Let's say this is 8 feet. So that ratio of my height over this side is going to be 0.84. A tree, this side to this side, it'll be a little bit bigger, right? It'll be like, say, 20 feet to like 25 feet. So this would be 25 feet now. This is the size of the tree. And then the moon would be like 50 billion miles, right? So this would be 50 million over this. This would be, I don't know, whatever would make 0.84. 60 million, let's say. I'm just making up numbers as I go. But the point is, though, no matter how tall the structure is, me, the tree, or the moon, the height from here to the moon, that ratio stays the same. Okay, so now, big deal. right? So how is that useful, knowing those ratios stay the same? Here's how it's useful. Look at this equation I'm about to create. Let's say I wanted to find the height of a building. I'll put it in black here. Here's a building, okay? Skyscraper building. Don't make fun of my drawing, please. Let's say I'm standing right here, and from the building to me, let's say from the building to me, this side is, I'm standing about 1,000 feet from the building. Okay? Remember, this is still 40-degree angle. So when I look at the building, the angle of elevation, when I look from the bottom of the building up to the top, this is still 40 degrees. So whatever that building is, I'll call it X feet. I know that the ratio of the building, watch this, the building to how far I'm standing, 1,000 degrees or 1,000 feet. What would the ratio be? What was the ratio with me standing there? What was the ratio with the moon? It was 0.84, huh? So watch this now. I can figure out the height of the building without actually directly measuring it, knowing that the ratio is always going to be 0.84. Look at the height of the building is X. How far I'm standing away from it is 1,000 feet. Look at 0.84. How would I get X by itself here? I got a simple equation now. How can I get X alone here? X divided by 1,000 is equal to 0.84. How would I get rid of this 1,000? Wouldn't I multiply it? It's the opposite of division. Watch this. Look at what happens. X equals 8,400. Again, I just figured out the height of the building. Knowing that this is 40 degrees, this is 40 degrees, and I knew the distance between me and the building, I could figure out the height of the building of 8,400 feet. Just by knowing the angle from where I was standing and the angle of elevation, I can figure out now using trigonometry. What I just did is trigonometry. I know that no matter how tall these sizes are, the ratio of this to this is always going to be 0.84. Now, on your notes, let's first define a trigonometric ratio. Write that down on your note guide. I'm going to elaborate a little bit more on what I just did. If it was a little bit kind of confusing, don't worry if it's a little confusing. I'm going to elaborate more. The trigonometric ratio, the ratio of two sides of a right triangle. The ratios always stay the same for right triangles for any given acute angle. You can continue here. Here's that. Go ahead, copy. What do I mean by the ratios always stay the same? What do I mean by that? Well, what I mean is, remember when it was 40 degrees? The example I just showed you? If this angle is 40 degrees, that's an acute angle. It's less than 90 degrees. If it's 40 degrees, the ratio will always be 0.84 of the side opposite to the side that's touching the angle.
Where do you get the ratio from?
Well, here's how. You just figure out how long these sides are. It just so happens if this is 40 degrees, this side, whatever that is, to this side will always be 0.84. This side to this side, 0.84. This side to this side, 0.84. The ratio stays the same eternally, forever. What if I had? Well, let me pause. Let's define the second word, and we'll elaborate some more. Tangent. What the heck is a tangent? Here we go. This is the first ratio you're going to learn. Out of 3 ratios in summer school, this is the first ratio. The tangent ratio is the ratio of the side opposite to an acute angle to the side that's adjacent. The ratio of the side opposite to an acute angle to the side that's adjacent. Right. There'll always be acute angles inside a right triangle. Copy this down and I'm going to elaborate some more. If it's a little confusing right now, don't worry. It's always confusing when you're starting to learn trigonometry, but you'll get the hang of it very soon. Stay focused. Last 2 lessons, you're done. Stay with me. Franco, were you with me during the regular year when I did trigonometry?
Yeah.
Oh, so you're going to SOHCAHTOA. Remember SOHCAHTOA? Oh, so you got this.
Are you a part of Hurricane today?
Say again?
Are you a part of Hurricane today?
I'll be your partner today.
Nah, I don't want to.
Here we go. Look it down on that first side there. It says core concepts. What do I mean by opposite an acute angle? Well, look at, go ahead and highlight A for me in this triangle. Go ahead and highlight angle A. Put a little arc there. De Casas, how many sides does a triangle have?
3.
Right. Here's angle A. Watch this. The side that's opposite to that angle would be right here. Look at it. It's not touching that angle, so it would be the side, this is the side that's opposite angle A. The side that's touching angle A would be this side and the hypotenuse, right? These 2 sides are touching. Out of the 3 sides, 2 sides are touching angle A and 1 side's opposite. So all the tangent means is the side that's opposite the acute angle over the side that's adjacent. Adjacent just is a fancy word for touching. So if I'm next to Sedon right here, if I stand side by side him and I'm touching, you can say I'm adjacent to Sedon. So a side that's adjacent to an angle is a side, look at this side's touching the angle. That's just a fancy word for adjacent. Now, isn't that what I was doing with my moon example and my tree example? This is 40 degrees. What was the side that was opposite 40 degrees? Well, it was me. Look at it. I'm the side that's opposite 40. And what was the side that's touching 40? Well, it's the distance between me and the angle. How about my skyscraper? What's the side opposite the 40-degree angle with the skyscraper? Well, it's a skyscraper. And what's the side that's adjacent to 40 that's touching it? Well, it's the distance between me and the skyscraper right here. Notice how the ratio was always the side opposite to 40 over the side that's touching 40. The tree was opposite 40, and then here's the side that's touching 40, the distance between me and the tree. The height of the moon was opposite 40, and then the distance between me and where the moon was right over on planet Earth was the side that's adjacent to 40. Now, going back. That's the tangent ratio. Go ahead and draw another right triangle in the notes section. Let's call this angle X. Let's call this side A. Let's call this side B. And let's call the hypotenuse C. All right, the tangent, tan is short for tangent. The tangent of the angle X. What side is opposite to angle X? A. That's opposite over, what side is touching angle X? C and B, and we're always going to pick the one that's not the hypotenuse. So, Moreno, you're right. Side C is touching angle X, but when we look for the adjacent side, we pick the one that's not the hypotenuse. In this case, B. So go to put B here. The tangent of the angle is the side that's opposite the angle over the side that's touching it. And that fraction will always be the same no matter what, for whatever degrees this angle is. Stay with me, La Casas. Finish strong, finish strong. Corridos later. It's all right. Here we go. Next one. I'm going to draw another right triangle in the note section. Let's call this angle Z.
A.
No, Z. And let's call this side A. D as in dog or B as in boy?
D.
D as in dog.
And M.
M as in Mary.
Oh, fine.
A what? My bad. Say again? You're the man. Now just write it down, though. Watch this now. Tangent of Z. For an extra stamp.
A.
Hit it. Over. Close.
What do you mean? Oh, B.
So give it to me. Tangent of Z is what?
A and B.
A over.
B.
Nice. A over D. A over D is in dog. Notice Y. You got to figure out Y now. This is second to last lesson, you guys. Here's angle Z. The side that's opposite. If you ever, by the way, if you ever forget, just it's right here. Tangent. The length of the leg opposite angle A over the length of adjacent. So look at this. Opposite to Z, A. Boom. Adjacent to Z, touching it, D. Boom. We're rocking and rolling. You remember this, Franco, sort of, kind of? Nice. You're going to have an easy time these last 2 days. You can get your grade up big time now. Congrats. Last example for now. Here's a 90-degree angle there. A different letter.
Z.
Z is in zebra.
Yeah. Q.
Nice. I love it. Let's find the tangent of Z now again. The tangent of Z. So the angle, it's always of an angle. So the angle is Z.
Q.
Hold on real quick. So look at, tangent is length opposite over adjacent to the angle. So look at the angle Z, focusing on angle Z. Someone besides the Casas and Ioanovich. That's Q. Nice. Side opposite to Z, it's not touching, it's Q. And side adjacent to Z, the side that's touching is R, even though Z, what was that? T. Even though T is touching Z, we don't pick the one that's the hypotenuse. We pick the one that's not the hypotenuse. So the adjacent would be R. So far, so good. All right, you guys are with me. I like this. I was figuring you guys would be more asleep, but you guys are with me. I love it. I love it. All right, almost done. Almost done. Okay, cool. All right. Go ahead and flip the page. Look at example 1. On example 1, the directions are: find the tangents of the acute angles in the right triangle. Write each answer as a fraction and as a decimal rounded to 4 decimal places. So, It says find the tangent of the acute angles. What are the two acute angles here? There's two of them. Can someone name them for me? You're awesome. Munoz, R and S. They're acute because they're less than 90. Angle T is not acute because that's equal to 90. It's got the box. So far, so good. So what we're going to do is we're going to find the tangent of R. Let's go reverse first and you. Go ahead. Right, and we're going to do both. And then we're going to find the tangent of S also, both. I love it. You guys are with me. I'm like, what the? I thought you guys were going to be like dead. Like mentally at least. You guys look dead this morning. I'm very impressed. All right. It says around in 4 decimal places, so let's do R first. Here's angle R. What's the side opposite to R? 45. Go right. 45 over adjacent. That's a hypotenuse. Careful. So it's going to be 24. There you go. Let me calculate that on my calculator. Watch this. Let me go to my Desmos calculator. Stay with me. I got it ready. So let's see. 45 divided by 24. Watch this. 45 divided by 24. They say round to the 4th decimal. This only goes to the 3rd decimal, so I'll keep all 3. 1.875. Yes, for the tangent of R. Or was it Z? Yeah, R. So go to right. Here we go. Stay with me. 1.875. Okay, real quick, before we finish off here. Now, what does that 1.875 mean? Well, it means this. Don't write this down. Just pay attention to the master here. Yours truly. Watch this. If I were to make this right triangle bigger, look at it. Don't write this down. Look at it. Then whatever this side is, let's say it's 60, and whatever this side is now, let's say it's 28, the ratio would be still 1.875. Or what if I made the triangle smaller? Look at it. Still a right triangle. Look, it's still right angle. It's still whatever degrees this is, it doesn't matter. Now this side over this side is still going to be 1.875. What if I made it smaller? Okay, it's still a right triangle. This side to this side will still be 1.875. Okay? Let's do the tangent of this S, and we're done. At least for now. Yeah. So let's see, tangent of S. So here's S now. What's opposite to S, Ivanovich? Adjacent. 45. Let me type that crap in my calculator. 24 divided by 45. I'm going to round to the nearest 4th decimal. Watch this. 24 divided by 45. Nice. So to the 4th decimal. 1, 2, okay, here's so the 3 is in the 4th decimal place. I look to the right of it, it's not 5 or bigger, so it's going to be 0.5333. It's the 4th decimal. So go to right. Approximately, because here we're approximating now. 0.5333. So far, so good? Okay, now, you still don't get why trigonometry is still important, and I understand that. But right now, you're starting to see that there's something up with these ratios. There's something strange going on. before we close and before I stamp you, before we go on break, watch this. Look at this. Let me go back to my tree and me and my skyscraper. How big was the angle again, the acute angle, for all these examples? 40, right? 40 degrees. And remember, no matter how big the triangle got, the ratio is always 0.84. Some of you maybe have seen these funky buttons on a calculator. Watch this. You're going to start using them now. Look at my calculator. If I go to function, some of you have the iPhone calculators and you've seen these weird buttons that you have no clue what they mean. Watch this. You see the button that says tan? See that? Cosine and sine we're going to do tomorrow. That's the last lesson right here. But tangent, look what if I put tangent? Let me press tangent. And let me put the degree of that acute angle, 40. Again, I'm going to put the 40 degree right here. Look at what the calculator spits out. Put your seatbelt on. What did it put up? Run that to the nearest tenth, or the nearest second place. 0.84. So that's exactly, see the 0.84? That angle, 40 degrees, no matter how big or small, the ratio will always, the tangent ratio will always be 0.84. And I can do astronomy, I can do GPS systems, I can figure out the distance between any two points in space. If I know it's a right triangle and I just get one distance, I can figure out any distance. It's potent, it's powerful. Get your stamp sheet out. I'm going to come around and stamp you. We're going to go to break.